Hello everyone, you're watching PC Helper and welcome to another video in the Python 3.9 tutorial series. If by the end of this video you feel like you have learned something today, then please leave a like and also don't forget to subscribe to PC Helper for regular content. So in this video I'll be showing you how to make a program for binary search in Python. We've already discussed in the last video about linear search, and first of all let's see how we'll be approaching the program for binary search. Later we'll be talking about how to make a program, but first of all with the help of this image I'll be telling you how we approach our list in binary search. So let's start from the very basics. So for binary search there is one condition that a list should be already sorted. So as you can see, this list is sorted. It is in ascending order, as you can see 4, 5, 10, 15, 20 and so on. So we have not discussed in our tutorials yet how to sort a list, so we'll be discussing it later. So for this example we have taken a list which is already sorted. Secondly, let's take a look at the indexing of a list. It starts from 0 and ends at 14. So here 0 is a lower index and 14 is a higher index. And if we add the lower index and the higher index and divide the result by 2, we get the middle index. So in binary search, we'll be again and again calculating the middle element, and we'll be comparing if the middle element is equal to the number we are searching for. If it's not the case, then we'll be changing the lower index and upper index according to the situation. And then we'll again calculate the middle element and again check if the middle element is equal to the number we are searching for. And if not, that's not the case again, then we'll again change the lower and the upper index and then again calculate the middle value and check if the middle value is equal to the number we are searching for. So in this example, we are searching for 20. So as you can see, 20 is the fourth element in this list. So first of all, we'll be calculating the middle element. So m is equals to L plus h integer division 2. So we are taking here integer division and not the float division. So if the division is 2.5, the result of division is 2.5, then we'll consider the second index. So for the first time when the program will run, m is equals to L plus h divided by 2. So 0 plus 14 divided by 2 is 7. So our middle element is the seventh element. Now we will check if m is equals to the number we are searching for, that is 20. But that's not the case because it's 35. So we will start an if conditional statement here. So if the middle element is less than the number we are searching for, then we will change our lower limit to the number which is in the middle right now. And the reason why we'll do that is because if the middle number is less than the number we are searching for, then we know that all the numbers less than the middle number are of no use to us. Then we will change the lower index to this middle value and we will search for the remaining part only. So we'll just search this remaining half here. But in this case, our middle element is greater than the number we are searching for. So in this case, we will change the higher value and not the lower value, because if the middle element is greater than the element we are searching for, we know that this second half, which is greater than 35, is of no use to us. So now we will make this middle element our higher element. So as you can see in this second list, lower element is 0 and higher element is at the 7th index. And now we will again calculate the middle element. So 0 plus 7 divided by 2 is 3.5. So now the third element is our middle value, as you can see here. So now we will check if the middle value is equal to the number we are searching for. But in this case also 15 is not equal to 20. Now we will check if m is less than 20. So this m 15 is less than 20. So we will change the lower value to the middle value. So now our lower index is 3. As you can see here in the third example, lower value is equal to 3. Higher value is equals to 7. So 3 plus 7 divided by 2 is 5. So now our middle element is the element at 5th index. And now it is equals to 25. And as you can see, 25 is also not equal to 20. Now we will again check this condition. So 25 is not less than 20. So we'll come to this condition. So 25 is greater than 20. So now we will change our higher element equal to the middle element. So in the last case, as you can see, now this 25, which is our fifth element, is the higher element, and 15, which is our third element, is the lower element. Now we will again calculate the middle value. So 3 plus 5 is equals to 8, divided by 2 is 4. So the fourth element is our middle element now. And now we will again check if m is equals to 20, and here middle value is 20. So yeah, condition is satisfied, and now we can print that number is found, that this number 20 is present in this list. So now we know how to approach this program for binary search, and now we'll be making it in our PyCharm. So as you can see, I've already made this program for linear search. So I will be making some changes to this program only. So if you haven't watched my video on linear search, you can watch it first and then come to this video so you are not confused about what's happening here. So here also I have an example of a list which is in ascending order, which is already sorted: 11, 22, 33, 44, 55 and 66. The user gives an input. So we ask the user to enter a number and user gives this input, and in our function search we take two arguments. First is the list and the second one is the input that user has given. That is the number the user wants to search for. And in order to change this program of linear search into binary search, first of all, we don't need this I variable now. We don't need this variable. So first of all, we will need the lower value. So let's name it L. And lower value is equals to 0 initially. And higher value initially is equals to length of the list minus 1. Because the length of the list starts from 1, but the indexing starts from 0. That's why we have to subtract 1 from the length of a list. And now we have to change the condition for our while loop, because our while loop will run till our lower element is less than or equal to the upper element, that is the higher element. Oh my bad, less than or equal to higher element, because as soon as the lower element is greater than the higher element, it means we have searched for every possible number in the list. And as soon as this loop starts, we will be calculating the middle value, that will be equal to the mid is equals to L plus H L plus H, not J, L plus H integer division 2. So now when we have calculated the middle value, we'll be comparing it to the value we are searching for. So if the middle element of the list is equal to n, then we will print number found at position. Not position actually, it's position plus 1, and the index of this position will be equal to the index of the middle value. So it will tell us at which position, at which index the number was found. If the number is found, we will simply break out of this loop, and also we don't need this line for incrementing I because we don't have this variable I anymore. We'll also bring this else statement inside the while loop now, and we will just remove this line where it prints number not found, and instead of this we'll be writing another if condition. So if the middle element of the list is, let's say, less than the number we are looking for, then we will change the lower element, that is L, equal to the middle element, because we just looked at the theory and we know why we are doing so. Or else, so else means if the middle element of the list is greater than n, in that case we will change the upper value or the higher value H is equal to the middle value. And once we have done this, let's run this program. So now I've executed this program. It's asking me to enter a number. So if I'm entering 11 here, and when I press enter, it says number found at 1, and 11 is present at the first position. Now I will rerun this program and let's search for 55. It tells me number found at 5. As you can see, 1, 2, 3, 4, 5. So our program for binary search is working really good now. So I believe that is it for this video. That's how you can make a program for binary search in Python. So if you like this video, then please leave a like. If you have any doubt, you can write in the comment section. I'll try my best to help you out, and I'll see you guys in the next one.